All right, here we go. Number two, we want to state the interval in which the function is increasing or decreasing and just y equals x cubed. So before we can kind of jump into again, increasing or decreasing, we got to find our critical numbers. And again, just to reiterate, it's where your slope is zero or where your slope is undefined. Polynomial function, so you don't have any divided by zero, so your function doesn't, it's defined everywhere. So we're just going to solve for where does our slope equal zero, and when you solve for your derivative, you find the slope is zero at zero. So if we think then about our regions, we've got a region that's left of zero and a region that's right of zero. So from negative infinity to zero and zero to infinity. So I'm going to build a table again, and I'm going to talk about those two regions. Those will be my two rows that I'm going to talk about in my domain. And then I'm going to talk about whether we're increasing or decreasing, if it's a maximum or minimum. Again, if it's going from a highest point to lowest point, that kind of idea. So when I think about my factors for 3x squared, I could just do a column, just 3x squared. Or I can break it apart to factors like we did last one. X times x is x squared. What should make sense to us then, if you take 3x squared or x squared or a number of times by itself, the slope is going to be positive both to the left side of zero and to the right side of zero. So my slopes are positive, which means my function's increasing. So again, the rows are important because they're talking about my regions, and the columns that are most important are my slope column and my function column. So if we kind of take this to the next step then, and we always have positive slopes, everything's increasing, you can see that this point at zero, which in this case it's 0, 0, because 0 cubed is 0. At 0, 0, it's not a maximum and it's not a minimum. When you go from increase to increase, you're not at the top of the curve, you're not at the bottom of the curve. All right, so that's going to be something a little bit different. And when we talk about the second derivative rule, we're actually going to talk about the location of these tangent slopes. Here on the left-hand side, you see all the tangent slopes are above the curve. And here on the right-hand side, you see all the tangent slopes are below the curve. So if you ever have a situation where all your tangent slopes are above the curve, pushing the curve down, we're going to talk about this being concave down later. So this left-hand side of the function is actually a concave down section. This right side, all the tangent slopes would be underneath this curve, sort of lifting it up. So this side of the curve is concave up. So we're going to have critical numbers for both first derivative and for second derivative. But in terms of our question, is it a maximum or a minimum? It's neither, because it's not a region of increase to decrease, not a region of decrease to increase. All right, so those are things we got to check for.